What is up, my students? We're talking about the ways that you can or cannot find solutions. So remember, friends, that most of the time when we solve these systems, these two lines are going to crisscross at a corner point, okay? One time. There's one corner point where they crisscross. That's when you actually find a solution. Then there's some times where you cannot find a solution whatsoever. None. I like to use the empty set symbol. Those are the parallel lines. So remember, it's either once, nonce, or remember, all the time. Those are the same two lines are on top of each other all the time. So that's all the solutions. I think the nerdy way to say it is infinitely many solutions. So how does that relate to solving with elimination? Well, here's some things you might see or you should see when you're solving by eliminating variables. So like right here, when you actually have a single variable to eliminate, there's going to be something left over. So in this case, I have a 2x and a 4x, a 3y, and a negative 7y, gross. So if I'm going to make opposites to eliminate, I'm probably going to take this top times a negative 2. When I do that, I'm going to make a negative 4x. There you go, opposites. And then I'd have a negative 6y, and then I'd have a negative 30. So this stuff would cancel, and there's actually going to be stuff left over to find it, okay? So when you have stuff left over to find a solution, you're going to end up getting one solution, okay? So when stuff is left over, like a variable, when this y is left over, okay, you're gonna have one solution. Now something kind of weird happens sometimes, and you might see it right away when you're trying to make opposites, right? So here we have a 2x and we have a 3y, and then we have a 4x and a 6. I wanna make opposites, right? So I'm gonna solve by elimination, so I wanna make opposites. Now here's a weird thing that happens, friends. Negative 2 is going to be the same number that makes opposite x's and opposite y. So let's go ahead and do that and see what happens here really quick. So I'm going to make a negative 4x, I'm going to make a negative 6y, and I'm going to have a negative 20. Weird. So what happens? This cancels, all of that cancels, so I have nothing left over here, and then that's going to equal a negative 8. When does 0 equal negative 8, students? Never. Okay, so when the x values and the y values cancel, and you have numbers left over that don't make any sense, then you're going to have none. Okay, 0 is never going to equal negative 8. You're never going to find a solution to the system. They're parallel lines, friends. They're actually parallel lines in disguise. You can graph it and double check. Okay, so one thing is going to cancel, and you get one solution. Two things are going to cancel, and you get no solution, or in this case, you probably see it already. Okay, look at this, 2x plus 3 equals 10, same system, and then we have a 6x, a 9y, and a 30. I'm going to try to make opposites by using negative, ooh, oh, ooh, ouch, gone, gone, and then even more gone. Whoa, what just happened? That's actually the same line, friends. Okay, 2x plus 3y equals 10 is the same line as 6x plus 9y equals 30. If you look carefully, times 3, times 3, times 3. You took this equation, you multiplied everything by 3. That's the same line. Great job. You manipulated how it looks, but it's still the same line. If you don't believe me, go to Desmos, type in any equation you want, and then take all the numbers and double them, or triple them, or times 10. As long as you do the same thing to all of the numbers, the equation is going to stay the same. Well, the line is going to stay the same, excuse me. The equation is going to look different, but the line that you graphed is going to look the same. It's mapping right onto each other. Remember, that's when they coincide. These are coinciding lines, okay? So look for that. So if some kind of fishy happens when you're making opposites, if these two things cancel, they're parallel lines. You're not going to get any solutions. If all three if all three pieces, that's what I say, parts and pieces in one move. If all three parts and or pieces cancel, then it's actually the same line. You bet, because anything minus itself is 0. It's gone. Okay, anything, if you take anything away from itself, it'll cancel. So it's the same thing. All right. Anywho, that's one thing that could happen when you're doing this elimination. So one thing eliminates, you find a solution, and then if something fishy happens, it's either going to be one of those none or all things. Okay, goodbye.